What if our buildings weren't just put together with inert materials? What if they were grown using nature's own blueprint? Well, today we're going to dive into a pretty revolutionary material system called LMG1 that's aiming to do exactly that. Right, so this is the core idea, the big vision. We're not just talking about a slightly better concrete or a stronger type of wood. This is a whole different philosophy. It's about shifting from brute industrial force to, biological wisdom. It's about creating structures that are not only stronger and last longer, but are also born from a much, much lighter footprint on the planet. But to really get why this vision is so important, we have to talk about the problem we're actually trying to solve. And that problem, well, it's baked right into the foundations of our modern world, our total reliance on traditional building materials. And here's the scale of that problem. Ordinary cement and steel, the two workhorses of modern construction, they are responsible for a huge chunk of global CO2 emissions. Just look at the chart. That gap between where we are and where we need to be is massive. LMG1 isn't aiming for a tiny little improvement. It's targeting a radical, fundamental reduction. So how in the world do you bridge a gap that big? Well, you do it by learning from the absolute best engineer on the planet, nature itself. And that brings us to the solution, LMG1. You can think of it as a whole new bio-blueprint for how we build. At its heart, LMG1 is all about mimicking natural processes. The easiest way to think about it is honey, wood, stone. It uses mineralization, that's the same process that makes seashells and bones. It uses wood densification to make timber incredibly tough, and then it uses enzymes as a kind of catalyst to glue the whole thing together. The result? A structure that's so much more than just the sum of its parts. To really understand it, it helps to picture an LMG1 panel as a kind of high-tech sandwich. So now we're going to deconstruct it, we're going to pull apart the three core layers that make this material just so unique. Okay, so the whole system is built on this really simple but powerful structure. You've got a strong central core, the stone. You have these super tough outer skins, the wood. And then you have this brilliant interface that bonds them together, the living glue. So let's break each one down, and we'll start with the stone in the middle. So the stone core is what's called a geopolymer. Now this is a huge deal because it completely replaces that high-emission Portland cement. Instead, it's made from industrial waste products, things like fly ash and slag. And what's even crazier is that it's designed with these tiny microscopic channels inside of it, which actually sets the stage for the material to one day, potentially, heal its own cracks. Next up is the living glue. Okay, this is where the biology gets really clever. We're talking about a microscopic layer of minerals that is literally grown onto the surfaces of the core and the wood skins using microbial processes. So this isn't just an adhesive, it's a protective shield and a superglue all in one, and it creates this incredibly powerful, durable bond between the different materials. And finally, we have the outer layers, the wood skins. Now, these start out as just natural wood, but then they're compressed until they become as dense and strong as some metals. It's wild. This gives you a really beautiful but also incredibly durable exterior. The process can even infuse the wood with resins from the inside out, making it extra stable and weather-resistant. So, there's our sandwich. A geopolymer core, a biomineral glue, and super dense wood skins. So what happens when you put it all together? Let's talk about the payoff, because this is where we see some truly game-changing benefits. First up, the big one for our planet. The target for LMG1 is a 40% reduction in embodied carbon compared to the steel and concrete panels we use every day. In the construction industry, a number like that isn't just an improvement, it's a massive leap forward. And it's not just greener, it is stronger. The system is targeting a 25% increase in what's called flexural strength. So what does that mean in the real world? It means buildings that are more resilient, buildings that can actually bend and flex a little bit under stress without breaking. And what about durability? I mean, how long does this stuff last? Well, after being put through these really harsh aging tests that basically simulate decades of wear and tear in just a few weeks, the goal is for that bond between the layers to keep at least 80% of its original strength. That points to buildings designed to last way longer, with a whole lot less maintenance. But beyond just being stronger and greener, LMG1 is also designed to be smarter. Every single panel, every beam, gets what's called an LMG passport. You can think of it like a digital birth certificate that stays with that component for its entire life, tracking absolutely everything about it. And in practice, this means every single component has this completely traceable record.
You can see its unique ID, you can see its quality control results, performance data like the bond strength. You can even see a plan for its end of life, for how it'll be recycled. This creates total transparency, which is frankly a huge shift for the construction industry.
Now, all of this sounds absolutely incredible, right? But you might be wondering, how does something like this move from a cool idea in a lab to an actual skyscraper? Well, the project lays out a really practical and clear roadmap for how to get there.
The whole plan starts with what's called LMG core. That's kind of version 1, something that's totally achievable today, using that geopolymer core and densified wood. But the roadmap also points to the future. Later versions could introduce some incredible upgrades, things like a lightweight mycelium layer for insulation, built-in biosensors to monitor a building's health, and even components that can store energy.
And the rollout strategy itself is really smart and low risk. You don't start by building a 100-story tower, right? You start small, with things like non-structural wall panels, just to prove that it works. From there, you could use it to strengthen existing steel beams, helping them last longer. And all the while, that LMG passport is gathering data, building trust, before the technology moves on to more critical parts of a building.
And that really brings us to the final thought here. LMG1 is so much more than just a new material. It's a question. It's asking us to imagine a future where our buildings are part of a living, circular system. A future where our cities don't just stand against nature, but actually stand with it. It really makes you wonder, what would that world look like?